Thank you very much. So Martin, it's almost as if we collaborated, and a lot of what I say, you've said already, but this is good. So when you're writing medical research papers, before you start, stop. Have all the analyses been finished, and has their interpretation been agreed? If you haven't done this, well, then you're not ready to start writing. Are you familiar with the relevant medical literature? If not, you can't write the introduction, and you even more can't write the discussion. Do you need to collaborate with others on particular sections of your paper? If so, you need to liaise with them early on. Know your target journal and refer to their style and guidelines and follow them strictly, as Martin said. And when I'm writing, I often start with a map or an outline of what the tables and figures are going to look like, because then you can build your introduction, results, discussion around the tables and figures. And also sometimes it takes time to produce the tables and figures if you need to involve your statisticians, and that they sometimes are busy doing other things. You need to be not their second most important job. So the art of writing is rewriting. You never get it right first time. Vladimir Nabokov said, "My pencils outlast their erasers." John Updike, writing and rewriting are a constant search for what it is one is saying. And a more contemporary reference, the script writer from The Simpsons, his approach was he always finished one script for an episode before he went to bed at night. He said it was always going to be rubbish. He knew it was going to be rubbish, but once he'd done that first draft, he got up the next morning and it was very easy to revise the first draft into a good second draft. He said it was like an evil elf had broken into his office and had written this rubbish first draft, but then he worked on that to build a second draft. So, don't get it right, get it written, but then modify it. So this is routine for all of you. This is the main elements in a research paper. I'll rattle through some of these. So the introduction sets the context for the study. You need to introduce the subject area and say why it's important. What topic within the subject area are you addressing? And what's currently lacking in our understanding of this topic? And why have you done your study? And what does your study add to what's already known about it? As Martin said, really the editor is going to look for novelty. And sometimes the editor, if you can't get across the idea of novelty within the introduction, you might well have lost them. So methods. In the olden days, where a lot of research was basic science, the purpose of methods was to allow somebody to reproduce your results. Now, it's quite hard for somebody to reproduce ACST2 quickly. So really now the aim of methods is to succinctly describe what you do so that the reader can understand your methods. So the aim is no longer reproducibility, but it's just rapid understanding of how you've done your study. And then context, study design, study population, the sampling strategy if appropriate, describe the intervention, main endpoints used, how you collected your data, and how you analyzed it. Tables, figures, and web materials. Sometimes these contents are guided by PRISMA reporting standards, CONSORT reporting standards, but normally you need to make sure you describe your study population, particularly baseline demographics, and if it's a randomized trial, show comparability between the two groups, a CONSORT diagram if appropriate, and then associate the effects of your intervention, tables or figures, really keeping it very clear. And often journals restrict the numbers of figures and tables you're allowed, so you really need to make sure your tables and figures capture the key information. You can always put extra stuff into web appendices, but think very carefully as to what you put into your tables and figures. And as I said, I get the tables and figures straight before writing anything. So results, again, it's more or less, it's quite a dry part of the paper, this, isn't it, Martin? Results, it's really just stating what you've found. Try to avoid too much interpretation in results, because that belongs in discussion. But sometimes one or two lines just stating why you've done the analyses you have is important. So, for example, in the heart protection study, which we did ages ago, looking at simvastatin on vascular disease, that was originally designed as a study of to see if statins reduced all-cause mortality, but actually the main effect was on vascular morbidity and mortality. So we re-emphasize the results in that paper. If there are guidelines you need to adhere to, try to adhere to them, but sometimes I think these guidelines and reporting standards make for an unreadable paper or a harder to read paper. So I would never sacrifice readability for confirmation with reporting guidelines. If the guidelines insist you report various things, but they hinder the flow of your paper, stick them in the web appendix to keep the editors happy. So as Martin said, the people who you hope are going to read your paper are going to be busy people. So write it clearly so that somebody can easily read it and make it an enjoyable read. We're novelists as much as scientists when it comes to writing papers. As I said, put whatever you think is unimportant in the web, and indeed, if it's unimportant, ask yourself the question, does it really need to go anywhere? So the discussion is the exciting bit, really. You state the main findings of your study. You discuss the main findings of your study in the context of what you described in your introduction. What have you added to the literature and the evidence base? The relevance to clinical and policy is really important too. You should always discuss the strengths and limitations of your work. Sometimes we're a bit too reflective and we go on too much about the limitations and not enough about the strength. So just be balanced and don't put yourself down. The reviewers will point out limitations, believe you me. And then, there's always a line in every research paper, further research is required. Hopefully you ask an important question and you answer it definitively, but that's quite unusual, and normally you'll just open up other avenues of research. You'll clarify some things, but some things will remain opaque. And in your conclusion, this is where you really need to be punchy. It needs to be 1 or 2 lines, and it really needs to encapsulate the essence of what you found. Don't restate the summary. The conclusion is slightly different, and I often think of it as if I was describing the results of my study to friends in the pub, maybe at 11 o'clock at night, I need to give them a simple message that they could take home. Make sure you stick to the reference limit. Have a reference manager. I used EndNote. Keep it up to date. Don't try to put your references in by hand. It's just so inefficient. If you are going to add a reference in a paper, make sure you've read the paper. Nothing irritates editors or reviewers more than citing a reference which actually has no relevance to the point you're making in the text. And it's very common, actually, for people who've written papers on your subject to be asked to review them. And just make sure that if you have links, make sure they work. And then the abstract. Martin said it's the thing people will read, first or second after the title. But I always write the abstract after I've done everything else, because it's only when you've written the entire paper you actually really understand your data and you understand the message that you're trying to get across. It's been backwards and forwards through all your co-authors and for internal review in your institution, and that's when you write your abstract. It's a really succinct, snappy summary of your paper, normally structured in the standard fashion, and you need to convey the main findings, really focusing on the primary and possibly key secondary findings of your studies. And as I said, write it after the paper is finalized. So when you've finished, you haven't. You need to go through the paper really, really carefully, as Martin said, as a whole, with 2 things in mind. One, is it accurate? You're looking for internal inconsistencies, which is really bad. External inconsistencies are not so bad, not so obvious. But if the numbers don't add up within the paper, well, then you are in trouble. And then also look for style. Does it flow? Are there unnecessary words? I've been taught by Richard Peter and Richard Doll how to write papers, and they both believe in having no adjectives in scientific writing. Adjectives rarely add anything. So just get rid of it all. And if the opposite it makes no sense, don't say it. The untimely death of my beloved wife, for example, is never going to be the timely death of my hated wife. So if the adjectives add nothing, get rid of them. Revise it to correct any problems you find. Send it around to your co-authors, but they should have seen it several times before this. And sometimes it's hard to draw a line under a paper, so what you need to say to your co-authors is, this is it, it's been a long journey, final comments within 2 weeks, and it's then going into the journal. Otherwise, you'll just get into the perpetual cycle of revision and re-revision. So, publication, this is where Martin might be able to chip in, so shall we give Martin a microphone, and we could be the Abbott and Costello, the Laurel and Hardy,
Yeah.
the Ant and Deck.
Just to comment on your nice presentation, I often, with my PhD students, I had 24 of them who defended their thesis, we often wrote the introduction as well as the methods before we started the project. Because you need to go through the literature, you need to define your methods before you start the work. And it's actually not so bad to write it from the beginning, and then you have it already written when you should write your paper. It actually, in most cases, you can use that text more or less as you wrote it maybe 3 or 5 years before.
Yeah, particularly for a dissertation or a thesis, yes. You should be able to write the introduction before you actually start any of your work, right, in theory. So publication, how it works. Online submission is typical. There's an editorial process. Then we respond to reviewers, how to deal with rejection both intellectually and practically, dealing with the proofs, and interaction with media. So,
may I just comment on the proofs? Because it's really important that you read the proofs carefully, because it is a joint responsibility between the journal and the authors that everything is correct. And the copy editors and the typesetters that turn your text into something publishable, they are not scientifically trained. So they may sometimes make mistakes. And that's very important that you check every sentence, every figure, every table, and see so that not errors have been introduced to your text.
I can give you one beautiful example of where that went horribly wrong, not with me, but with Colin Bagent, who's the author of much of these slides. He was involved in an IPD meta-analysis of antithrombotic therapy, aspirins, clopidogrels, etc. And he wrote an analysis looking at antithrombotic therapy for the primary prevention of vascular disease, accepted by the British Medical Journal. He reviewed everything carefully. Then when he opened his British Medical Journal to read his major paper, he found in the conclusion what he wanted to say was antithrombotic therapy is not indicated for the primary prevention of vascular disease. The copy setters had forgotten the word not. So the conclusion was antithrombotic therapy is indicated for the primary prevention of vascular disease. But it was too late. Yeah. It had landed on 80,000 GPs' desks, and that ship had sailed.
That's such a terrible mistake. And we've also had one case recently with a p-value that was changed. Fortunately, we discovered that before the paper was published.
So online submission is now the norm. So as Martin said, editors receive many more papers than they're ever going to be able to publish. So triage is inevitable. Sometimes, as Martin said, it's immediately rejected following a relatively cursory review based on the editor's or the associate editor's judgment. But normally it's sent out for peer review to normally 3 or 4 reviewers with context, with relevant experience. The reviews are then considered by people like Martin and an editorial discussion at a hanging committee where they and your options are you reject, the paper gets accepted with minor revisions, major revisions, or accept as is, which is, as Martin said, almost never. Accept as is?
Well, no, that hasn't happened for years, actually, no. But we have another alternative that we have developed the last 6-7 years, and that is that we offer some authors the possibility to shorten the paper into a research letter.
Yeah.
And that has become quite popular because then you can get a research letter published in this well-known, respected journal. Yeah. And if you then want to proceed and publish a full-length article in another journal, that's allowed as long as you tell them that you have published this research letter and you cite that, and then it's not a dual publication. It's completely okay. So that's something that we sometimes suggest.
And then sometimes editors will suggest redirecting the paper to a sister journal, typically a lower impact journal, but as you do for the forum.
Yeah, it's the Vascular Forum that is our sister journal. Yeah.
So responding to reviewers, try to be polite. It's hard, but you must try to be polite. Yeah. So read the comments carefully, identifying any suggestions or comments that do require revisions to your paper. And sometimes these comments can be really helpful. And if you tackle this in the right way, you do make a better paper. So you prepare two things: a response, which should be brief, to the reviews, and a revised paper, checking that they're aligned. If you do disagree with the reviewer's comments or the editor's comments, then state why politely, and why. And your argument, so if you're going to change their mind, they need to be persuasive. They can't just say, no, I know I'm right, you're wrong. That tends not to fly.
No, I think that's not a good strategy. It's probably better to change something minor if you want to maintain maybe some of it, but change at least part of it. And then you sort of, in your cover letter, you sort of give the impression that you've changed dramatically, whereas you really didn't change that much. That's a much better strategy, I think. And also, what's important is not your arguments, but the changes in the manuscript. Sometimes I get revised papers where they changed hardly anything in the manuscript, but they wrote a long letter commenting on all the comments of the reviewers, and that is almost like suicide, actually.
As I said, be polite, but at the same time, if you know you're right, don't roll over. Stick to your principles, because really, it's a bit like being a witness in a court of law. You know your truth, and you know your evidence, and you know more about your study than the editors do. The editors are experts at producing readable papers, but you're the subject expert. So do stick to your guns where you think it's important. But as Martin said, pick your battles. Don't argue over every comma or semicolon versus colon. But if something's really important to you, and for example, you've done an ITT analysis and you don't want to do a protocol analysis, just stick to your guns on that one. And when you get reviewers' comments, it's often normal to feel angry. So respond, draft a response, share it with a senior, more moderate colleague, and just make sure that what you're saying is not nuts.
It's really a good idea to involve your co-authors in the reply in this way, because, as you know, every text is improved by 4 eyes. And that's how we work also within the journal. We call it the 4-eyed principle. Every important decision is made by at least 2 editors. And that is of the same reason that it's difficult for a single person to make good decisions.
So the revision is then reviewed by Martin and colleagues, and it might be sent back to the previous reviewers, which is why it's important not to be rude to them or about them, but possibly also to new reviewers, particularly if there's been violent or stark disagreement between the reviewers and the authors.
And we also have a principle that if it's complicated statistics, we often include a statistical reviewer in the second review round.
And then your revised document is once again reviewed at a hanging committee. And the decisions there are reject further revision or accept as is. So, sometimes you do go through this loop again, which often feels deflating, but if you're going around it again, you're highly likely to get in.
Yeah.
Because if they thought this was not a paper of interest to the journal, they would terminate the whole process, before now. Dealing with rejection, so it happens to everybody, and it's part of science and part of academic medicine. And sometimes some of your very best papers might be ones that were initially rejected. Rarely it's appropriate to appeal the decision, but you're unlikely to change the editor's mind. If it's not appropriate to go back to that same journal, just take a break, and then come back to the paper in a couple of weeks' time. Look at the critical feedback you've received, and then identify a second target journal and resubmit following their advice.
Nikolai Volodar's first paper on the aortic stent graft was actually rejected by the Journal of Vascular Surgery.
Impact factor 3.1, yeah, okay.
And it was published in Vasa, the German angiology journal. Yeah. And then it's been good for Vasa. They got many citations from that.
So as Martin said, dealing with proofs, really important. You get galley proofs, which are for author review and correction, and there's normally a very, very short timeline for this because the journal is keen to get your paper processed as quickly as possible from acceptance to appearance online. But you really need to be obsessional about checking the facts in the galley proofs. And then you'll find page proofs get sent to you subsequently, which is exactly how it will appear online and in press. It's unlikely that there'll be major errors between the galley proofs and the page proofs, but sometimes they can creep in. And Colin Bajan said that the missing knot crept in between the galley proofs and the page proofs. And then inevitably now, if you spent a lot of time doing a high-profile study, you'd like to have some interaction with the media. Sometimes it might be popular press. More often it would be industry or the academic media world. But you do need some media training because just because we're scientists and just because we're doctors, we're naive when it comes to dealing with the media.
The AVIS, we actually produce visual abstracts for all the editor's choice papers, and also we promote all the open access papers in social media. So we help you with that, which I think is important.
Yeah. So if you've got a press or a comms department in your institution, use them. They'll help you write your press release, which needs to be brief. You need to tell the journalists what they need to think and what they need to say, because they don't have time to read your paper and understand all the technicalities. So you need to tell them, feed them the lines, have quotes. The chief investigator says, this is a game changer. The future for carotid disease is stenting. Piotr Myślic, for example. If you deal with journalists without media training, you could get burnt. So do have some training, because sometimes they can just take you off down a rabbit hole, as we say in Oxford, and you could end up making comments about all sorts of things which might not be wise. So that's it from me.
See if there are any questions. Should we move on?
Thank you, both speakers, for this very good co-talk of yours. And do we have any questions from the audience? If no, then I would like to ask a question. I would ask both of you, what is your source of research ideas? Does it come more from your clinical practice or from reading research papers?
Should I start? Yeah. No, I think most of my research ideas came from my clinical practice. I've done research in many different vascular surgical fields. But of course, when you run into problems in your clinical practice and you start asking questions, the first thing you do is to study the literature. And then if you figure out that really we don't know what's best. I have an example. I've done a lot of research in acute intestinal ischemia, thromboembolic occlusion of the SMA. And then there was a colleague who phoned me, and he had treated a patient with an embolus to the SMA that had a very high didymer. And so he phoned me and asked me, because he knew I was an expert in the field, and so he asked me, Martin, is that normal for an SMA embolus to have a high didymer? I didn't have a clue. So then we started a project analyzing that, and it ended up with his PhD thesis, the guy who phoned me. So that's just an example how a clinical observation, and I have many of my PhD students actually have made clinical observations that they have discussed with me, and then we started projects around it. The same with popliteal artery aneurysm, for instance.
Two things I do. One, I make sure I'm not the cleverest person in the room. I surround myself by people who are cleverer than me, and often they have the good ideas. The second is often the questions will follow logically from one study will lead to another. For example, in the heart protection study, we studied normal dose simvastatin versus placebo, and that showed it worked. And then the logical next question, what about high dose versus low dose simvastatin? So ACST1 showed surgery was better than medical therapy alone for asymptomatic carotid disease. And then the collaborative group said, right, the next big question is, if you are to intervene, should it be stenting or surgery? So the questions, one study sometimes leads to a logical extension, and that's when you're really rolling. And then the final thing is, think what you've got locally. So I've been to South Africa, and they've got a lot of Berger's disease, HIV, arteritidis, and things like that. So if you've got lots of a condition in your country that is uncommon elsewhere, that would seem like a very obvious thing to study. There's no point us in the United Kingdom studying tuberculous pericarditis, because it just doesn't happen, but it's really common in South Africa. So think if you want to shoot zebras, go to Africa. If you want to shoot moose, go to Martin's house in Sweden.
Yeah, I rarely shoot zebras. But and one tip is also to read the guidelines, the ESVS guidelines, because the last chapter in each guideline is future research. So we always have identified areas where there's lack of research. So that's a good, actually, source of identifying areas where you need to study.
Thank you very much.